All right, I think we are recording here. Let me just confirm. Well, I have the option of stopping recording, but Zoom is kind of changing things around. So first couple of times I have to figure things out. All right. So last time I was showing you the idea of a balanced signal. We're going to get couple major concepts here taken care of during this class, during this lecture. So just bear with me because we might be jumping back and forth between certain ideas, but it's all going to make sense when all is said and done. All right, so when I was showing you the balanced signal, here is, there we go. You should see right now, you should see a microphone on the left, top left corner, in the top left corner, and then there's some sort of an input device. And on the bottom, right in the middle of the screen, just a diagram of a amplifier and a couple of signals applied to it. If you don't see it, let me know. All right. Okay, so let's say this is just a typical microphone. I just chose the SM58, Shure SM58, and there is a reason why I'm choosing that, because I'm going to make a statement that it is the best stage microphone ever. Right? And I'm serious about that. Okay. All right. So the microphone input, the microphone output, you can notice if anybody plays in a band or has anything to do with sound, you can see those three prongs. All right, so this is the male version of the connector, and here's the female version of the connector. Female is the input and the males are the outputs. Okay, so you can see that also, if I can zoom in, if you can see it, those pins are numbered: pin number 1, pin number 2, and pin number 3. All right, so that's this type of connector. It's called XLR connector, and the XLR, it stands for external line return, and whatever logic was applied to naming that sort of this sort of signal, kind of a device idea, it remains mysterious to me, but if you want, just go ahead and dive into the etymology of things. But anyways, there are 3 pins that apply to a balanced signal, and one of the pins is ground, but so-called virtual ground, and we'll talk about that. And there are 2 other pins, pin number 2 and pin number 3, and they are supplying a signal and a mirror image of the signal all at the same time to the input device, input of the amplifier, and this is called a differential amplifier. Right? So only if the signal provided into the input is a double signal and basically a mirror image of itself. So if it is 180 degrees out of phase, so here's a signal and here's the same signal, but it's 180 degrees out of phase, and only if that is provided to the input, then you're going to get something on the output. Right? If these 2 signals are in phase, which is basically if this was not a mirror image but a copy of that, so if it was reversed and mimicking the whole thing, if you get signal in phase, then you will not get any output. You will get quietness, you get silence on the output. So the idea is those red things that I put on These would be the spikes of some sort of noise that is being introduced into the cable. Now, when it comes to a noise, it is going to affect all the conductors in that cable in the same way. So the noise will be in phase. See that? Here's a noise, and it's the same noise is affecting the other cable because the cable is just right beside it, the conductor, and so on. So the noise will be in phase. So whatever comes in phase is ignored. So the noise will be quieted out. So that's the idea of that. The microphone sort of passive devices, and they have the output in the range of 1 millivolt peak to peak. Then these are very, very weak signals. But if you use that sort of signal transfer method, then weak signals can be transferred over a long distance. Long distance, you're talking 100 feet, 200 feet, or whatnot. And it is very, very efficient way of transferring the signals. Now, what I have done also, just to demonstrate what's going on when it comes to balanced signal, an unbalanced signal as opposed to balanced would be, there would be no mirror image supplied with the signal as well. So it just will be ground and a signal. Right? So obviously in an unbalanced signal, any kind of noise that is being provided along with the signal, and if the noise is big enough comparing to the signal, then it's going to affect the quality of the signal. Right? So what I have done is I have multi-simmed it. Maybe I should give you the multi-sim file as well, so you can play with that. All right, so same thing. We have a microphone, and here is the pinout of the output of the microphone. Notice there's pin number 1, pin number 2, and pin number 3, just like the well, input or balanced input to the mixing board. All right, so here is something that's called an operational amplifier. Now, sometimes I'm going to show you things that might look slightly intimidating at first, but I'm going to give this thing to you anyways, because maybe you are not into it at this point, but at some point you're going to get involved with this sort of electronics. And when you come back to this lecture, it's going to make sense, or it's going to make sense to you right away. So here is something that's called operational amplifier, and it is connected in a way that is arranged as differential amplifier. Okay. I'm not going to go into any of the details on how this thing is connected. I got this thing from the website, from this website right here. You can go to it, and there's some more detailed description on how things are being connected. Or you can also research things like operational amplifiers, and that's a kind of fascinating topic all on its own. But anyways, so what do we have? I'm just going to disconnect the inputs of the oscilloscope just to make things a little bit clear. All right, so what we have here is we are simulating the output of the microphone by having some by having the AC sources. So here is the signal that's coming on the pin number 2, and here is the signal that's coming onto pin number 3. So there's a signal, and it's connected in a way that they are mirror imaging each other, and they're in phase. And they're in phase as far as timing, but they're out of phase as far as the actual signal is being delivered. So once we connect the oscilloscope, I'm going to show you what that means. Then, in line with each of those pins, I have introduced another AC source, and that is going to be the noise. That's the simulation of that noise. And these two are in phase, so they were going to be ignored, right? But just to show that things are going to be ignored. So these two, they are the signals, and they are out of phase, 180 degrees. And these two are the noise that is affecting both conductors, um, and um, um, and they are in phase. Okay. So, sorry, I just had a phone call here. So let's take a look at the oscilloscope when we're going to connect channel 1 of the oscilloscope to the pin number 2, and channel 2 of the oscilloscope we're going to connect to pin number 3. So if I bring up the scope, these are the signals that we're getting on the oscilloscope. Let's just start the simulation. And what I'm going to do is I'm going to turn off channel 4. The output I put on channel 4 because the color of the channel 3 is kind of like a purple magenta, and it's not very visible on the screen. So you could tell here's pin number 2, pin number 3, here's signal going in, and here's another signal going in, and they are mirror image of each other. And what do we have on the output? Well, we do have a waveform that coincides with pin number 2. Right? So that's well, nothing unusual. We got a signal on the input that's smaller, and we got a signal on the output that is bigger, so nothing unusual. Well, let's experiment with this thing just a little bit here. I'm just going to close the oscilloscope view. What if I reverse the phase of one of the inputs to make them both in phase? So now they are out of phase, and I'm going to reverse one of them. I'm going to shift it 180 degrees. So now these two, let me just get the oscilloscope here, and I'm going to turn off the output, and I'm going to start the simulation. Now you can tell that those two signals are in phase. Do we have any output? No, the output is just a straight flat line. So if anything comes in phase, is being ignored. Okay, so we have just proven that that if you get signal out of phase, it's treated as a signal, and if there's signal in phase, it's being ignored. Okay, let's stop the simulation and put this thing back in phase again, so it's out of phase. Right? Now let's introduce the noise here. So we have 0.5 millivolts peak to peak for that. So let's just make the noise a little bit bigger than it usually would be, but 0.2 millivolts peak to peak, or actually peak. And the same thing over here. So because the noise affects both conductors the same way. All right. Okay, so now if we get what are we getting here? Oh, 0.2 volts. Let's get 0.2 millivolts. That's why. Simulation is still going on. 0.2 millivolts peak to peak. Okay, that's why. All right. Now, what we see here is we have two signals out of phase, and we have the noise introduced into the line. So let's see what the output of that thing is. Oh, look, the noise is being ignored, and still the output is nice and clean waveform. So this is basically how the balanced signal idea works. The noise is in phase and it's being ignored, and the signal is out of phase and it's treated as a signal. And this is the differential amplifier. You can build that your own, and you can experiment that if you wish. All right. But this is a pretty much a classic circuit introduced into the mixing boards. In one way or another, there could be slight modifications, a little bit this way, a little bit that way, but this basically is the idea of a balanced signal. So you can transfer low-level signals over a longer distance and still have that arriving at the destination and being processed while the noise is being ignored. Right? Okay, so I hope you enjoyed that little show. How are we doing? How are we doing? Okay, talking about the time. All right, so we're talking about the PA systems. PA system stands for public address, description, and audio system consisting of audio sources, amplification equipment, and output transducers. We talked about that last time. The purpose is to process, amplify, and distribute audio signals over a large area. Some definitions, and you remember this screen from the last class. There are input transducers, so this whole model always applies, and sometimes it's nesting. This thing is being nested, so you can see it as a big picture, and you can see those models within the same system on the micro level. So you will have a lot of small ones, and then those small ones are going to, well, make up one big system as well. Excuse me. All right. So definitions, more definitions. Not in the written. Okay, so basically what I'm saying is that whenever you do the installations, pay attention to the contract, because sometimes some of the definitions might differ, might vary from one company to another. Sound reinforcement. We're talking about sound reinforcement. Any system which amplifies one or more sources for a live audience. Okay. Public area, what are we talking about? Public address, PA, public announcements, background music, good old rock and roll stage. That's what I'm saying. Calling it theater, church, arenas, and whatnot. It could be a local fast food restaurant having few ceiling speakers pumping the elevator music, or the elevator pumping the elevator music as well. Now, excuse me here. Where am I? Looks like I muted my microphone. All right, so and then we're talking about sound enhancement. Sound enhancement is mostly applied to some like meeting rooms, conference environment, and so on. And then there is that hearing impaired systems. This is assistive. These are assistive systems, quite often used in churches or any kind of environment that speech exists, and people who do need a little bit of assistance with hearing what's being said. Then there are systems in form of earphones and whatnot, right? So what I'm saying is that the whole thing, all those stuff is sound reinforcement, but sometimes in the contract you're going to see PA systems. So just make sure that whenever somebody is talking about in the contracts, but if you're not sure, then just call them. What do you mean by this? What do you mean by that? This is just a small example of wording, and try not to correct people as they go along, because sometimes people are in the business for much longer and they deserve the right to deviate from, slightly deviate from the way that the terminology should be used exactly. Okay. All right. So the whole thing is sound reinforcement. Now, sound enhancement, if I mention something, the big difference between these two here is for public address, so public announcements, background music, and you know that you are listening to the sound coming from the speakers. There is a huge amount of amplification, and there is no mistake that, yeah, this thing is being pumped through something. Now, sound enhancement usually used in meeting rooms, conference environment, also churches as well. and certain theater applications. In this case here, the sound is set up in a way that the people in the audience, they should have the illusion that there is no sound system at all. A properly adjusted sound system this way creates the effect of the listener thinking that they hear the person and they hear the sound coming from the person's mouth, and that's it. You only notice that the system exists if somebody pulls the plug and all of a sudden the system disappears and things get quieter. So that's how properly set up sound system is set up. Okay. So these are the biggest differences. And then also this here involves with some time delays and whatnot. If somebody is interested in more about this kind of things, just talk to me and I'll set you to the right direction. All right. We're also going to talk about something that's called a constant voltage distributed system. All right. What I'm going to tell you is, for example, if you have an amplifier and the output of the amplifier is 8 ohms. In order for the maximum power transfer from the amplifier to the loudspeaker, you should have the impedance, which is the resistance, so to speak, of the receiving device. The impedance should be matched with the impedance of the source. If you have the impedances mismatched, you are not going to get full power transfer from one device to another. Some of the power is going to go into heat. All right, so let's say if you have one channel of the amplifier, which is 8 ohms output, and you have one 8 ohm speaker, no problem. You connect one to the other, and well, the name of your uncle is Bob. All right, all right. So no problem. But what if you have like 4 speakers? And if you want to connect it to the same channel, if you connect them in series, those speakers, you're going to have 8, 8, 8, 8. So you're going to have 32 ohms altogether if you connect those speakers in series. So that's no good because the output of the amplifier is still 8 ohms. So, well, but if you do the series parallel connection combination thing, so that means if you connect 2 speakers in series, which it's going to give you 8 ohms. Sorry, it's going to give you 16 ohms. And then another pair, you're going to do the same way. So you're going to have 2 pairs of speakers connected in series, each pair. And so you're going to have 2 16 ohm combinations. And then if you connect them in parallel, you're going to have that impedance. So you're going to go back to 8 ohms. So you do a series parallel connection and you're going to get 8 ohms, and that can be connected to the amplifier, and you still get the full power transfer from the amplifier output into the system of speakers, into network of speakers. Okay, well, so that's no problem. Just a little bit of tweaking, and you're okay. But what if you have to connect a whole school, and let's say you have 300 speakers? Can you do that series parallel connection with 300 speakers and still come up with 8 ohms on the to the amplifier? Yes, you can, but that would be quite a chore. And it's not a very practical thing to do. And then what if all of a sudden, somewhere halfway down the hallway, somebody wants to add another speaker that needs to go to somebody's office? Well, then you are back to square one, and you're going to have to disconnect all the speakers and reconnect the whole network. So you get 8 ohms. So that's not a very practical thing. Well, so what we have is we can implement something that's called a transformer. And I'm not going to go into the details how transformer works, but what I'm going to tell you is the transformer. Here's the transformer. It transforms voltage from one end, from the primary to the secondary. It transforms current from one side to the other, and it transforms impedance from one side to the other. Wow, that's a cool thing, right? So what does it transfer? What does it put through? It keeps the power. So if you have a power of 10 watts on the primary, you are going to have power of 10 watts on the secondary. Transformers are very extremely efficient devices within maybe half to 2% of losses. So pretty much insignificant. So for this purpose, we can just say 100% power gets transferred, right? So if the primary has certain voltage, and because it has certain number of windings on the primary coils, and then you're going to have half of that on the secondary. So if you have 100 volts here, you're going to get 50 volts here. But in order to keep the power, because power equals voltage times current in this case, so if you have the voltage, you're going to double the current. That's the beauty of the transformer. Right? And then if you have certain impedance that accommodates the output of this device, whatever here, and then there's going to be impedance of this, this transformer is going to adjust the transfer of the power. So the impedances, so sometimes you can use it as impedance matching devices. Right? So let's say we have an amplifier that's 8 ohms output. So this would be at 8 ohm primary coil windings of the transformer. And let's say we have a bunch of speakers that are also having connected, they're connected to smaller transformers. And the big one here, it has a low impedance, which is about 8 ohms, connected to the amplifier. The secondary has a high impedance in the range of like 1500 ohms or so, about that. So there's a high impedance side. Okay, so now on the speaker stations, you have the reverse. You have the low impedance connected to the speaker, which would be 8 ohm side of the transformer. And the high impedance is tapping into the line, tapping into the line, tapping into the line, and so on. So you see, you can just parallel keep adding those speakers until you run out of power. So whenever the speaker and the transformer, well, these are the 8 ohms, so that's not changing, but there are some that's called the taps on the transformer. So the transformer sometimes is being tapped halfway through the winding, or maybe a full length of the winding, maybe quarter length of the winding. And depending on how this thing is tapped, because there are cables coming out of conductors coming out of the taps of the transformer, depending how it is connected, depending on that, it is going to draw more power or less power from the whole river of signal, from the whole bus or from the whole line. So it is considered, well, for the most part, we have something that's called 25-volt systems and 70-volt systems. What is a 70-volt system? Well, a 70-volt system is that if the whole signal is at the full power and the amplifier is at the full volume, you're going to have 70 volts RMS going through the line here. And with the current capability, that will accommodate the power that the amplifier is able to provide. And then each speaker, let's say it is tapped at 2 watts, and this one is tapped at 1 watt. Let's say all the speakers are tapped at 1 watt. So this one is tapped at 1 watt, this is tapped at 1 watt, and so on. What does it mean it's tapped at 1 watt? It means that at full volume, it is going to drain 1 watt from the whole system. So if the amplifier is 100 watts and you get all the speakers tapped each at 1 watt, you can connect 100 speakers. And then you're going to use the whole full capability of the power of the amp. So the calculations are simple. If you have all of them tapped at 2 watts, you could only connect 50 or so on. That's how it works. Right? So this is considered a step up transformer because it's stepping up the impedance. And then you got sort of like a higher voltage, low current, and that's basically the formula for, well, this is the recipe for efficiency. So you're always going to have constant voltage. If the volume is turned down, you're not going to have 70 volts. Maybe you're going to get half of that, but it's going to be constant all across. And then each speaker is going to grab as much current as it needs in order to accommodate the power that it needs. So that's why it's called constant voltage distributed system. This way, you can just run a whole cable from one end of the hallway to another, and just tap in with the speaker station, tap in with the speaker station, tap in with the speaker station, and so on. So these are called step-up transformers because they're stepping up the impedance, and each speaker station will have step-down transformers to accommodate the impedance from high to low, from high to low, from high to low. So the high impedance of the step-down transformer is connected to the line that's coming out of the main transformer. The amplifiers, those commercial PA amplifiers, sometimes they come with this transformers built in, and you're going to have something that's called output that's a 70 volt or 25 volts, depending on what system it is. Then if you don't have that, you can still get a commercial amplifier without the transformer. You can buy external transformer and connect it externally. Right? Except you need to make sure that the power capability of the transformer is, well, the transformer is able to handle what the amplifier is able to put out. So some of those are bigger and heavier transformers, right? And these are smaller because they go, we'll keep going with that. So next few slides is going to show you what I'm going to show you what these actually look like, right? So here is the main bus, typically 18, and I just go American wiring gauge. So 18 or 14 gauge, unshielded. Sometimes there's a requirement for shielding it, but this is basically to prevent any kind of interference coming out of those speakers. Maybe there's some sensitive equipment in the ceiling as well. But usually it's unshielded is fine for this, if you just want to have that working. So typically it's 18 to 14 gauge, unshielded, 2 conductors wire, stranded speaker wire, right? So these are the step down transformers and these are the loudspeakers. All right. Okay, next slide here. This is the same thing, but just presented a little bit different. So I'm not going to repeat explanation of that. You can analyze it when you look at it. All right, so here's another way of showing that. Here's the input of whatever the audio signal. Here's the signal conditioning circuits would be their processing. Here's the output of the whole system, which is the amplifier. And look, it's connected to the primary windings of the step-up transformer. And then you get a whole line going all the way through the hallway. And you see here, these are the smaller transformers. These are step-down transformers connected to the speakers or loudspeakers. And you have taps. And those taps are 1, 2, 5, 10, and these are in watts. So this first speaker station is tapped at 1 watt, which means at the full volume, this speaker station is going to drain 1 watt for itself. And then this one here is tapped at 2 watts. So this speaker station at the full volume is going to grab 2 watts out of the whole system. And here's a horn speaker, and it's also tapped at 1 watt. So the whole system, as it is connected right now at the full volume, is going to go 1, 2. So 2 watts plus 2 watts, 4 watts. All right, it's going to grab out of the whole system. So if the amplifier is capable of pulling out 200 watts, oh, well, we can connect many more of these speakers into this line. It is important that those speaker stations are connected in phase. So if they're connected out of phase, if this one is reversed here, polarity is reversed, it's still going to work. However, if you have these 2 speakers beside each other and you're standing beside those 2 speakers, you are going to hear the sound coming out of phase, and it's going to be annoying and you will not know why, right? Because at the cycle of the signal, when the membrane is pushed out, the other one's going to be pushed in. So and vice versa. So you're going to hear kind of some kind of weirdness, right? And so of course, the sound volume might as well drop because one of them might start canceling. They might start canceling each other, so the volume might drop a little bit. So it's important that those speakers are connected in phase, right? This is what a typical PA system amplifier looks like, and well, these are the controls for the inputs, and here's the master volume, and here's the back of that. See here, this is the output of the amplifier. This is the power output. So you have the common line, so the black wire will be connected to, and then depending on what kind of speakers you're connecting to. So if you have 4 ohm load, you'll be connecting these two. If you have 8 ohm load, you will be connecting these two. And if you have 16 ohm load, you'll be connecting these two. And if you are going to connect 70 volt constant voltage distributed system, you'll be connecting black to common here and the white or red to the 70 volt system, which means that that transformer, the step up transformer, is built into this amplifier. Right? Now, this is what the speaker stations look like, and I'm pretty sure you have seen those in the ceiling all over the place. So well, here's the front baffle of that, and here is the 8 ohm loudspeaker, right? And it is connected to the step down transformer. Right? And out of these, the primary of the step down transformer, you have a bunch of different wires coming out, and you have a label on which color of the wire is associated to which tap. So yellow might be 2 watts, orange might be half watt, and so on. And on the secondary side of the transformer, these wires are permanently connected to the 8 ohm terminals of the speaker. So depending on how you're going to tap those, though, you're going to connect the common wire and one of the colors that you're going to decide how you're going to tap that speaker station, and all the other wires you're just going to leave unconnected, not connected, disconnected. It's a good idea to secure the endings of those wires that they don't touch by accident anything else, and not to cause any trouble. All right. Now, this is also something that's called a 70 volt speaker or a paging horn. In closed environments such as conference room or a dining room or whatnot, these speakers are, or hallway, like a school hallway or hospital hallway, these are the best. But if you have a large production hall, or if you have well, open environment, so it's not enclosed, paging horns are better because of the way they distribute, physically they distribute sound. And when it comes to paging horns, usually the further away you stay from that, the better you hear the sound. All right. And that's as much as I'm going to go into details of that. Also, what you can have is volume controls, and the volume controls are basically, you can see this, there's stages, there's steps, 1, 2, 3, 4, and this is not a smooth action. And whenever you join me in the lab there, join us in the lab, we have those volume controls, we have those speakers, you'll be able to touch them, you can play with them, you can connect them if you want, right? But these are, on the other side of this volume control is a transformer, just like that one, but just a little bit differently made, but it's the same idea, and it has taps, but instead of connecting different wires to the main line, the choosing of those different wires, different taps of the transformers is done by this volume control. So it's like a click, 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 click. All right. So what happens if you want to connect the volume control? What you could do here, instead of going from the main line, going straight into the speaker station, you would go into the input of the volume control first, and then from the output of the volume control, then you go into the speaker station, and then whenever you uh, adjust the volume, you're not going to affect any other speaker stations. Right? You're just going to tell this the transformer to grab more or less power from the whole system. And as long as you have enough reserve of the power, you're not going to affect any other stations. All right. So that's what it looks like. That's what the transformer looks like when it is, well, it's a magnification of the transformer. So you can see orange is a 2.5 watt, yellow is 1.25 watts. So this is considered 2 watts. This is considered, 1 watt or so on. Just a general rule, whenever you're installing school PA systems, so remember the school PA systems, they would have the speakers in the hallways, they're called hallway speakers, and they would have those classroom stations on the wall. So if there's an all call, the volumes have to balance out. So the general rule is that all the classroom stations, you tap them at 1/4 watt, and all the hallway speakers, you tap them at 1 watt. So if there's an all call being made, then you get the proper balance of the volumes all throughout the building. So here's another example of that. Sometimes there's no wires, but they're just tabs here, and you can get spade connectors and you can connect that, so just like a less mess here. And you can see that all those wires are being exposed. So if you choose to connect just the common, let's say black here, common, and will be the 1 watt. 1 watt will be this one here. So black and yellow, that will be the whole thing tapped at 1 watt. All the other ones, just cut them off, tape them out, or just make sure that those endings are not exposed and hanging freely, being free to touch anything that comes their way. Right? Yeah, that's what it looks like sometimes on different transformers. Instead of wires, you have those tabs and you can just plug things in. All right. Going the wrong way. All right, so here is the volume control, what it looks like. Right. And this one here, that comes from the main line. It comes into the input of the volume control. And from the output of the volume control, it goes into the speaker station. If you need to control one of the speakers, sometimes you need to control the whole area of the speakers. Also, you gotta make sure that the wattage capability of the volume control matches the power that is going to be taken by the whatever the amount of speakers, and they do come in different ratings when it comes to wattage. Right? Just also you need to make sure that when you choose the boxes to go to accommodate those volume controls, keep in mind that those transformers can be quite bulky, so make sure that the boxes that you install or have the boxes installed for you by another contractor, they are large enough to accommodate transformers. Right? Now, this is what the typical classrooms, not classroom stations, you see, I keep calling that, speaker station looks like. These two wires are the 8 ohms low impedance, and all the other ones are the wires that you would use, just 2 of those, to tap into the main line, right? Another thing here, a practical kind of advice, whenever mounting the ceiling speakers in the ceiling tiles, these are soft tiles, so you can't just mount those onto the soft ceiling tile and expect that to last, because temperatures going up and down, moisture's going up and down, and the gravity combination of that, it is going to make things sag and it can actually fail through. So those speakers come with brackets, just like that, and sometimes they're just rails. And there's also a back box that needs to be installed. And here's here's the speaker station. So those rails here, they rest on the support railing of the ceiling grid, ceiling grid. Okay, so this whole speaker station, this is just a pot light here, but same idea. Um, that device is not hanging on the tile, it's actually being supported by the frame, and the tile just covers that. All right, so that's the first part of that. Second part of the PA systems, yeah, just as I said, we're going to go a little bit over. So if you need to go to another class, please go ahead. I'm just going to continue with a few more minutes, and you can catch that on our YouTube playlist. Right? What are we doing here? Yeah, we still have people. All right, so here is the stage gear, typical stage gear. Wherever that is, I know where that is. It's from my home country of Poland, and this is in the mountains, and they're getting ready for the New Year's Eve. It's becoming quite a thing every year. So every year they put the stage up, and then they take it down right after. All right. Once this thing is done, so why am I showing you this? I'm showing you this that the staging industry, or the entertainment industry, it is a very serious thing, and if you can find yourself having a job doing just that, you could be satisfied for the rest of your life career, right? Just like any other profession. All right, so once this thing is done, that's what it looks like. I think this is from 2000 something, or way before COVID. So from here to here, that's what things look like. Now, live performance, typical stage setup. Now, what we're distinguishing, there are two, we're kind of dividing two kinds. We're recognizing two basic kinds of stage setup, and it's analog or digital, right? The good old analog system. Digital is same as analog, except it's not, but it's basically mimics the analog version. It just involves less wires, and you get a little bit more control over certain things. Right? So let's take a look at the typical setup. Analog or digital? Let's just say this is an analog system here. What do we have? We do have a mixing board here. And this part of that is called front of the house. Front of the house is that the mixing board is somewhere within the public seats. Front of the house, that's where the public seats sits. Right? And the mixing board would have different effects and processors and whatnot to process the signal. And then there's a long distance, sometimes 100 feet, sometimes 200 feet, and you get something that's called a stage box. And in that stage box, you get all bunch of inputs. And what kind of inputs? They're balanced inputs, just the way that I showed you, right? So 200 feet or so, then because if you have balanced inputs, then you can transfer those signals over a longer distance without worrying that the noise is going to affect that. All right, so here is everything that is plugged in. Now, when it comes to analog, you're going to have a thick cable. How many channels that stage box is able to accommodate, you're going to have so many physical lines. So if this is a 24 line snake, because that's what they're called, snakes, then you're going to have 24 cables inside that big cable. So you got 24 cables inside the big cable. And on the other side here, you get some sort of fan out. So they fan out, and and they are numbered, and you just plug them in, channel 1, channel 2, channel 3, and so on until you fulfill it properly. And those are channels, they are numbered, and depending on which number you plug in here, you are going to have let's say the microphone is plugged into the input number 1, and then the cable number 1 is plugged into the input number 1. So there you go. Here is your microphone controls right here on strip number 1. This is the analog way of doing things. Then what we have is we have something that's called returns, okay? Which is not marked. Yeah, it's marked with the yellow line here. So the output of the mixing board is also being sent down the same snake, but the gender is reversed. So this would be these cables here would have the cable would have male ends, and inputs on the mixing board with female ends, but now the output of the mixing board has a male end, so the cable has to have reverse gender, so the female end on this side and male end on the other side, right here. And from there, the return is being connected to the amplifiers or the amplification section. Why don't we have just amplifier here and one big long speaker wire going to the speakers? Well, it is because that the speaker is considered low impedance, so sometimes 4 ohms. And if you have 200 feet going, or 250 feet, sometimes 200, 300 feet, that resistance itself on the cable adds, and it's going to be comparable enough to be affecting the whole performance of the speakers. So that's why all the amplifiers are supposed to be as close to the speakers as possible. So you're going to have the mixing boards at the front of the house with the signal processing, and the signal is being sent to the stage box, and the stage box is sending it to the amplifiers, and the amplifiers are on the stage because they're supposed to be as close to the speakers as possible. So you use this least amount of wiring that goes between the wires and the speakers. Right, then you get something that's called stage monitors, but we're not going to get into it. If somebody wants to talk more about the stage gear setup, please talk to me. I've done it for years. Right, now when it comes to digital setup, right, instead of having all bunch of those strips, so the mixing board is going to get a little bit, well, significantly smaller. You don't need all those sliders on one-to-one basis. You need a bit of a section of the slider, and you need a screen. So the screen, digital screen, is going to say, okay, you're controlling sliders 1 through 6. And then whatever you have the control section, you're going to control that, Then you can flip the screen to control the channels from 7 till, well, 12 or whatever. Then automatically those are going to adjust themselves physically, and then you're going to be able to control still the same section, physical section, but on the screen you're going to control different section of the whole thing. So that's basically plus all the effects and limiters and whatnot. The signal processing is built into the mixing board instead of having to have external pieces of equipment. Some people prefer it one way, some people prefer the other way, but the digital way seems to be taking over the whole industry. Right, and then when it comes to digital, you have the stage box, and you don't have a bunch of cables connecting through here, so one-to-one channel basis. You're going to have, well, data cable, Cat5e, connecting from the stage box into the input of the mixing board, and you're going to eliminate all those wires that you need, all those heavy wires. Right? Well, the advantage of that is you use less wires. The disadvantage of that is if there's one break, if one channel breaks, one cable break, one conductor breaks, you can pretty much zero out, pinpoint which channel is bad, and you're just not going to use it. And you have all the other ones available to you. If there is some break in the digital cable, like the Ethernet cable, Cat5e cable, then the whole thing is affected. And it sounds like the skies are falling, because the amount of noise that is being generated by a bad Cat5e cable, it's just beyond any imagination. Your eardrums can break, not really, but you can actually hurt the amplifiers and speakers. All right, so that's that. Now, this is a typical mixing board. Well, these are those 2 strips, cheap one. You can pretty much pick it up on Amazon for about 60 bucks, some of the mixing boards, for your home purposes or DJing purposes. So there's a channel strip. Here's here's that balanced signal input, and it also has an unbalanced signal input. All right, so you can choose which one you want. And you have the bunch of processing here. You have a pad. Well, I'm not going to get into details, but here's the channel, the strip that processing that one channel. Here's channel number 2, and so on. You got some other channels that are not equipped with the balanced, and you have outputs and so on. And you have the main volume control that you can raise the volume of the whole thing once you have the balance of other devices. Right? So that's a small mixing board. Here's the input. The input section of that. So if you look this way here, or sometimes those inputs are coming in from the back. Okay, so here's the typical 2-channel, channel 1, channel 2, and some other devices you can plug in. So this is balanced, and this one here is balanced slash unbalanced. So it still has 2 prongs, but not in this physical configuration, but in the 1/4-inch jack. It's just like a banana plug configuration, and it's also balanced because it has those 3 pins, but arranged on the banana plug. Okay. Well, different mixing boards have the main kind of bus processing arranged in a different way. Some of them have equalizer, some of them have built-in effects. Here's the main volume, here's the headphone volume, and here's the other channel, and quite often it's called a monitor. So if it's the main, then you can have the whole thing going in mono, and if you use main and monitor, then you can have the whole thing going on in stereo, or you can split. This is the main goes to the front of the house, and the monitor mix can go right into the monitor stage monitors. I can talk 5 hours about that. I'm not going to. Again, if somebody wants, talk to me. I'll get you into the topic. Now, those bigger mixing boards are nothing else but the bigger version of the small mixing boards. This is just what 2-channel, and this is, well, 24-channel, which is more than 2, but they are pretty much the same. And some of them are a little bit, they have a little bit more controls, but that's basically how the bigger mixing boards are different from the small mixing boards. You can plug in more channels, but if you take a look at each individual channel, you control them on individual basis, and then you have the main volume control section right here. All right, now, so that was the analog type of. Now here is the thing. So this, my mouse is, I apologize, my mouse is jumping through things. All right, so this mixing board here looks bigger. This is the analog, typical analog mixing board. Right? Now this one here is it looks smaller, but it costs about 20 times more than the one that looks bigger and more complicated. It is actually more complicated. This is Yamaha CL5, and if you want to know how much it costs, then I'm not going to tell you that, but just go on Google and type the Yamaha CL5 and find out how much it costs. That's going to be an interesting homework for you. All right. Again, you're going to have a link here. If you want to click on that, once you download this presentation in PDF form, it's going to give you a little bit more information on how this thing works. You need to be educated on using this type of equipment already. This is how complicated things get, but this is pretty much the industry standard. The nice thing about this one here is it has all the effects built in, all the signal processing, and it has a memory. You can set up a whole band, and you can store the setup information on a jump drive and put it in your pocket. So if you are traveling with a band from one place to another, you don't need to carry this equipment with you. What you can do is you can have the whole setup on the jump drive, and you can request the sound crews to provide you with this particular model of the mixing board, and all you can is just plug in your jump drive, load the setup in, and there you go. You might have to do a little tiny light duty tweaking just to accommodate the room acoustics, but everything else is set up. So that's how the technology is evolving right now. As far as controls, sometimes you can take advantage of the Bluetooth or the wireless technology. Now, here's a typical kind of a country setup. There's a stage, and look, there's no wires between the control systems and the stage. All the stage gear is set up on the stage, and over here you only have the control screens of controlling wirelessly the stage gear that is on the stage. That's pretty cool, right? It eliminates a lot of tripping hazards and makes efficiencies I can see that. Oh no, that's not a chat line. It was just an information. Sorry. Um, so the technology, of course, it costs accordingly. But if you're serious about that, you can rent this thing. You can work for a company who does that. Again, if you're interested in that kind of stuff, talk to me. All right. Another thing here, I'm going to show you this. Here is something that's called as Shure microphones, Shure SM57, Shure SM58, Shure SM57B. And if you click on that link, you're going to get the comparisons on an explanation on which one is going to be used for what. And I'm going to ask you on the test for stage mic. Vocals, what would you do? SM58 or SM57 or SM57B? If you wanted to do a studio recording, which one of these three would you use? If you wanted to amplify a guitar, acoustic guitar, which would be better? SM57, SM58, or SM7B? Please find out what the differences between these three microphones are, because I'm going to ask you on a test. All right, now here is another YouTube link comparing different sound processing by different microphones, different brands. Use your headphones when you're watching this this one here, because you're going to hear some differences when it comes. This guy is doing a pretty good job, right? We have already talked about the balanced and unbalanced signal, so I'm not going to expand on that right now. And I'm pretty sure you remember this diagram from the last. I'm just keep including that. Not going to talk about, because we already talked about that last time. But I use this presentation for more than one class, so and sometimes if it's a presentation that stands on its own, I'm going to talk about that, but we already talked about it last time. And here's the references, because I need to include if I got any images from the internet. All right, so that's pretty much it for today's class. We went 7 minutes over. Please keep those labs rolling in. Next week we start the in-class in-person labs, so make sure you come to school ready, which means you need to get your safety glasses. We don't need safety boots in that room. We just need safety glasses, and we don't need a hard hat in that room. Just need safety glasses, but we need to have them. And please bring your tools, so you don't have to be uncomfortable sharing, asking, or begging and borrowing tools from your friends. And I already have posted the videos, the preparation videos for those two labs that we're going to perform during that lab session. Please watch those videos. If you don't watch, you're going to feel very uncomfortable in class. Okay. And I want you to feel comfortable. All right, cool. Thanks, guys. And I will see you when I see you next time. Thank you.